Hello everyone. Welcome to Codex Tech Rust Learning video blog. In today's video, we will cover our next Gophercises exercise. And this one actually are two exercises combined into one. So this exercise is to cover two problems from HackerRank website that was covered in the Gophercises website. One is the camel case problem and other one is Caesar cipher problem. In short, for the camel case problem, we need to uh, we need to receive a string input from the user, and then we need to count the words in that camel case string. In the Caesar cipher problem, we will receive an input string from the user, and using the Caesar cipher algorithm, we will rotate those characters using the offset provided by the user in the input. So let's look at the code quickly. This will be a short and quick um, exercise. So there are no libraries that we need to use. So let's open the main source code file. I did not create two separate files because it was a simple solution. So in first we are starting with the main method. We are taking the user input, and then I created two methods. One is for the camel case count, another one is for the Caesar cipher encryption. So I can uncomment one of these, run it, see the solution, and then I can comment it out and uncomment the other line. So first, let's look at the camel case count. So we are taking the all the arguments from the command line, pass it to the method, and then in the camel case, first we will loop through all the arguments. So it can simply be just one input string, but I just made it that where you can have multiple input strings on the command line and it will still work. For each string that is entered, it will look for the word count. So assumption from the beginning is that it is a camel case input. We are not validating if it is or not. So we'll start with the count one because at least there is some input. And then we get all the characters in that string. And every time there is an uppercase letter, we will increase the word count. So pretty simple. And the great thing is that Rust standard library already provides this is ASCII uppercase method. So I just call it on the character and it will return true if it is an uppercase. And then I just simply output the value that is it a valid sorry, is it the what was the input and total number of words in that input. So if we run it, so I would need to start with the target. I have to go and hrrank camelcase and then simply target debug hrrank. So now we have to provide some camel case. So let's say if I do 1, 2, 3, and for the input it prints the message input value is 1, 2, 3, and the word count is 3, which is correct. And just to test one more, so another we can try is save changes in the editor. So it is 5 words save changes in the editor, and it correctly printed 5. And I can actually combine these two calls. So if I can want to enter two strings, it will print then separately save changes in the editor has 5 words, and 123 has 3 words. If I had not the camel case, it was just lowercase t, then it will print 2. So that covers the camel case part. Pretty simple. Next one is Caesar cipher. So for Caesar cipher, um, we are still taking the same arguments that is on the command line. But for the Caesar cipher encryption, we need 3 inputs. One first input would be the total length of the string that we want to encrypt. Second input would be the actual string, the original text, and third will be the offset. So here that's what we are doing. From the second argument, we get the original text. From the third argument, we get the offset. So offset will tell us how many characters do we want to offset the current character in the Caesar cipher. So if you know Caesar cipher, so let's say it is entered A and we have offset 2, then it will change A to C. So two characters forward. Uh, Next we are, so this is simply the original text offset, and this is the first input, which is the length. So total in string size. Since we have that input, so we can optimize our Rust string a little bit. We can call the string with capacity. So because we know if the total string length is 13, then we're not going to have more than 13 characters. Encryption in the Caesar cipher does not increase the input size in the output. It stays the same. It just rotates or offset the characters. Next, we are going to loop through all the characters in the string. So there is a helpful method in the standard library chars. So it will return all the characters as a Unicode. And then we are checking if the character is not an ASCII alphabet. So that's also another helpful method built in Rust library. So we are only interested in the ASCII characters, nothing outside the ASCII characters, although there is a Unicode support. But for this exercise, we are only looking for ASCII characters, and if there are numbers or special characters like hyphen or $sign or anything, we will skip that. We're not going to encrypt them. So this is ASCII alphabetic, just returns if the character in that string is an alphabet or not. If it is not, we just add it to the encrypted text string that will be the output, and we just skip the remainder of the loop and go to the next character. If it is one of the ASCII characters, then we are checking if it is an uppercase or not, and this is just to get a base value, because in ASCII uppercase A is 65, and I believe the lowercase a starts at 97. So from 65 to onwards, 26 characters or 26 count is all the uppercase letters. So we are just trying to find out if it is an uppercase letter, what is the base value. So we are using the helpful is ASCII uppercase. Again, this is provided by the Rust library. We don't need to implement anything. And then we are just getting the base value, which will be an unsigned integer value. So we are saying what is, if it is uppercase, so we just get the first character in that range, which will be A, uppercase A. If it is lowercase, then lowercase a will be the base range. So we get that value as an integer and store in the base. We'll see later how we are using this one. Then next we are converting our alphabet itself to an ASCII from ASCII character to the integer value. So that that we got, and now we are normalizing. So this is where we are using our base value and the actual character. So if it is a C, which will be 67, and since base A, the base value will be 65, so it will return 67 minus 65, so it will return 2. So value, there are 26 alphabets, so value will be between 0 and 25. So 0 will be representing A, either uppercase or lowercase. We don't, it doesn't matter for our implementation. So it will return that as the base value. C will return as 2. So this is our normalized. And the reason we are doing this one is so we can rotate. For instance, if we get towards the end and the character entered by the user is Z, that will be 25th in the count, or I mean alphabet count was 26, but offset was 25. Then if our offset is 2, we have to move 2 character forward, so we want to rotate it around and then go from Z to B. So Z plus 2 will be, Z in the base offset is 25, and then we go to 0 and 1. 1 will be B. So that's the reason we are trying to normalize and then rotate the text. And for the rotation, we are using this formula here on this line number 63. So we got the normalized byte or the normalized character. So again, if it is Z, then it will be 25. So we are using the offset, which is how many characters we want to advance. So in case of if it was 2 offset from Z, we want to add 2 more. And we are using the modulus operator and then divide by 26 the number of alphabets. And then we add the base to it. So that will rotate the whole value from Z, although we go from 25 plus 2, 27. But since we are using this modulus and then add base, so it will rotate it around and we'll get the value 1. Then we push that rotated text back into the encrypted text, and finally we just output that string value. So let's see this in action. So first I will have to do cargo build, ignore the warning. So now, as I said, we need to enter first the number of characters. So let's start with something simple. So we'll say, just take all the alphabets and convert that or encrypt it. So we have 26 alphabets, and so count is 26, all the alphabets we entered, and then you want offset of 2. So A will become C, B will become D, and so on and so forth. So we can see A has become C, B has become D, and Z has become B. If I change offset to 3, Z will become C. So that's how we validate this is working. Next, we can try one more string. So we will try a string with a non-ASCII character in it. So it should skip that character. So so I have a test string that is 11 character long. So middle hyphen out, and let's do the offset of 2. So as you can see, it has properly converted this to an encrypted string. So M becomes O, 2 offsets, so M and O. Hyphen was skipped, and uppercase character O stayed uppercase. It did not convert to lowercase, so that was also handled. O, P, Q, and Z becomes B. So yeah, so these were some sample test strings for the encryption, but we can try anything that we wanted. So yeah, that was it for today's video. I will have links to the Gophercises website in the video description, as well as the link to this solution on the GitLab. I will provide that in the video description as well. Thank you for watching, and see you in the next one.